Hello everyone. Today we're going to finish lesson 5.2 and we're going to do day 4. And day 4 is going to involve modeling with the inverse of a linear function in the real world situation. So we're going to be taking a look at how inverses function in the real world. So here's an example. Modeling in the inverse of a linear function in the real world, we actually need to make note that sometimes in the real world, when we switch things, it's going to be out of context. For example, distance equals rate times time. So if you actually interchange the distance and the time, it actually does not it takes kind of like the meaning out of context. So therefore, let's make note that to find the inverse of a real world situation, we do not switch the variables. So instead, we're going to find the inverse by solving for the other variable. So use this example right here. D equals 60t. So in order to find the inverse, we're just going to actually solve for t by dividing by both sides by 60. So this is the resulting inverse of the original function. So again, in real-world situations, we do not need to switch the variable to find the inverse. Instead, we solve for the other variable. So, and then also we need to make a note that in real world situations, we have limitations sometimes, so we need to restrict the domain and the range. So here's the first example. A car's gas tank, which can hold 14 gallons of gas, contains 4 gallons of gas when the driver stops at a gas station to fill. So there is a 4-gallon already minimum there, and the maximum that the gas tank can hold is 14 gallons. And so this is the equation that you are pumping the gas. G equals 5t plus 4. So let's write down G equals 5t plus 4 as the original equation. And let's take a look at the first part. It says state the domain of the inverse function. So remember, when we are looking at the inverse, we are switching the x and y. So the input of the original becomes the output. So if we're looking for the input, which is the domain of the inverse, then we're actually looking at the range of the original, correct? So we're looking at the range, and the range of the gas tank, it goes by gallon. So the range is actually between the minimum of 4 gallon goes all the way up to 14. So the domain in this case, we're going to restrict it to the gallon of gas. It goes from 4 gallon to a maximum of 14. So that would be the restriction on the domain. Next, we're going to actually find the equation for the inverse function. So again, in order to find the inverse, we are no longer going to switch the variable. We're instead going to solve for t. So the first step is to minus 4. So we have g minus 4 equals 5t. And then next, we're going to divide it by 5. So we have t is equal to g minus 4 over 5. So this is the actual inverse of the function. And next, we're going to graph part B. So since we know that the minimum and maximum, we can make use of our x and y, the coordinates. So the x and y intercept. So we're going to let the gallon be the minimum, which is at 4. So when g is equal to 4, t is going to be 4 minus 4 over 5, which means 0. So we have the point 4, 0 as one of the points. So 4, 0 is right there. And when we're going to let g equals, let's show it here. G equals the maximum, which is 14. So when g equals 14, we got t equals 14 minus 4 over 5, which means 10 over 5, which is 2. So we have the point 14 comma 2. So 14, 2 is like right there. And we're going to draw a straight line connecting those 2 points. And let's do that. So here is the function in graph. So that's what it looks like. And finally, taking a look at the function, interpret the meaning of the inverse. So basically, this inverse is a function that gives the pumping time in terms of the amount of gas. So it's time in terms of gas. which is gallon. Okay, so time as a function of gas. And that's the interpretation for this problem. Let's take a look at another example. A swimming pool containing 600,000 gallons of water is drained. So it's going down, the water. And the amount of water W in thousands of gallons remaining is given by this equation. So let's write down the equation. And so the first thing we're going to do is restrict the domain again. So state the domain of the inverse. Again, the domain of the inverse is the range of the original. So the range in this case is going to be the amount of water that is being drained. So here's the range, the water. So the domain is going to be the water such that there is a minimum going to be 0 when it's all drained, right? And it's going to be at the maximum of 600 thousands of gallons. So I'm just going to use 600 to represent the gallons, 600, and then it's in thousands. So here's the equation. And to find the equation for the inverse, we're going to solve for the variable t. So in first step, we're going to do is minus 600. So we got W minus 600 equals negative 20t. Divided by 20, we will have t is equal to W minus 600 over 20. And that is going to represent the inverse. To graph it for the next part, we're going to let W equal to 0, which is the minimum of amount of water. So that's going to be T equals 0. Actually, we're going to let W equal to 0. And we are going down at 600. So when the water equal to 0, we have 0 minus 600 over 20. And that's negative, divided by negative. So actually, you know what? I made a minor mistake here, dividing by a negative. I do not see that negative right there. So we need to rewrite this as negative 1 over 20 W plus 30, my mistake. And so this is going to give me positive 30. So I have the point 0, 30, which is like right there as my first point. Second point, I'm going to let W equals the maximum, which is 600. So using the same equation, we're going to have T equals 600 minus 600 divided by negative 20, which gives me a 0. So at 600, the time is at 0. So that would actually make sense because at time 0, we have the full tank of the swimming pool, which is 600,000 gallons. And then it takes 30 hours for the water to go to 0, which means that's how long it's going to take for the water to drain. So here is the linear equation, that the graph that represents the situation. So it's going to take 30 hours to drain. Notice the slope is negative because it's going down because we're draining water. So we're losing water. That's why it's negative, and that would make sense. And what does this mean for the last part? Interpret the meaning of the inverse. So the inverse is actually the inverse represents the time in hours to the pool that has been drained as a function of the amount of water that is being drained in thousands of gallons remaining in the pool. And that is the meaning of the interpretation. The discussion question here calls for how do you find the inverse of a function and how is the original function related? This goes back to the general steps from yesterday's lesson on how to find the inverse. And here is the review of the list of steps again. First, we're going to replace the f of x with y. And then next we interchange the x and y and solve for the new y, and finally replace y with f inverse of x. And then again, as a suggestion, you should always verify to make sure that you got the inverse correctly by applying the composition functions to make sure that you're getting x for both of them. So those would be the general steps in an actual linear function that you are looking for the inverse. And that will be the end of the lesson for today. So go ahead and go to Google Classroom and get started with your homework assignment. Have a good day.